Okay, we do a quick recap. All right. So a lot of my students, when they're doing moles, they hate moles. And then finally, when they're doing electrolysis, they will say, actually, moles not that bad. All right. And then when they do organic chemistry, then they said, oh, electrolysis is so much easier. Okay. So now let's just recap. Okay. So this is the notes from last week. Okay. You don't need to copy again. I just want to recap what we did. Okay. All right. So first thing is by now you must know your ionic compounds very, very well. Okay, Ken? So if you're not sure about the ionic compounds, go back and watch the old videos from you just key in MEC. You know the link I sent you to video. Okay, the link I sent you. The the that channel of mine, all the recordings of the previous lessons are all there because I record it every week. So you just go and see. Okay, you just go and see which chapter you don't know, go and look back the videos. Okay? Can? So all the videos are there, and it's very important that you know because ionic compounds, okay, ionic compounds are essential that you know them in order to do this chapter. Okay, so just do a quick recap. Where can I try? Okay, wait. This Microsoft, you have to. It has to be in when you are doing it. If not, okay. Let's start. Good morning, Jonathan. Don't close it tight because there's something wrong with the thing. Just leave it like that. Yeah, it clicks by itself. You don't have off it already. Okay, so what we were doing previously is we were talking about how one, two, three, group one, two, and three, and then five, six, seven, and hydrogen. Okay? How everybody in group one will always become positive one, everybody in group two positive two, everybody in group three positive three, everybody in group five negative three, everybody in group six negative two, everybody in group seven negative one, and hydrogen is a positive one ion. Okay, this part you must memorize. You must know this by now. Okay, you must look at the periodic table, and even if you don't know, okay, even let's say you really, really don't know, although you have learned this like a few thousand times, when you see sodium, you actually cannot remember sodium is in what group. Okay? Hi, Ian. Did they give you the notes last week? Did they give you the notes last week? Did you all take one for him? Oh, you only took four. No, okay. Um, did you watch the video? This is, huh? Are you in the WhatsApp group? Can you? Okay. Um, uh, yeah. Are you in the group, Noah? Can you just put Ian's number there and then no, then later ask Mr. Kong, please add it in the group. Okay? All right. So sodium, let's say you really, 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 really don't know sodium. You look at the periodic table, sodium is in group one, it will form positive one. Okay, Can this last week's now. We're not doing it now. I'll just recap what we did last week. Okay, so you have to know this. You have to know this because if you don't know this, it's very, very hard for you to do anything. Okay, so for example, when ionic compounds form, Okay. For example, sodium and chlorine. This is what we did last week. Okay. I'm doing a recap because I know you all never study. Okay, so sodium is 281, group 1. Chlorine is 287, group 7. So we already know how does it form an ionic compound. Sodium will say, I give you 1 electron. Chlorine will say, yay, thank you very much, because both of them want to achieve full outer shell. Remember that? So sodium gives that 1 electron and becomes Na positive 28. Chlorine receives that 1 electron, becomes 1 negative 288. Correct? And the positive and negative combine together. They love each other so much, they form the ionic compound sodium chloride. So sodium chloride is an ionic compound. When you see a compound now, you already must know, is it an ionic or a covalent? How do you know? If it's metal and non-metal, it is ionic. Okay, metal and non-metal ionic. Non-metal and non-metal, it is covalent. How do you know whether it's metal and non-metal or is it a metal? You have to see the periodic table, you already know. Okay, so these are things, skills that you must have to go to the next part. If not, you can't look at me and say, teacher, how I know? You can't look at me and say, teacher, ionic or covalent. These are basic things you must know. Okay? Alright, so I give you something simple to work with. If the valence electron is 1, 2, or 3, it is a metal. If the valence electron is 4, 5, 6, 7, or 8, we count it as a non-metal. That's the easiest hack already. Okay, valence electron 1, 2, 3, group 1, 2, 3, we count it as metal. Group 4, 5, 6, 7, 8, we count it as a non-metal. Okay, something simple. So you need to have this prior knowledge. Okay, and this prior knowledge you've been learning from year 7, year 8, year 9, year 10. You've been learning the same knowledge. Okay, so you need to know this knowledge to retain. All right, so now we continue. Okay, understand this part? This part understand easy, right? Okay, so in electrolysis, okay, in electrolysis. Okay, so electrolysis, last week I gave you the definition. When questions ask you definition, it is what it actually is. It's not how you feel. Right? You cannot write, I feel electrolysis is something breaking apart. No, you cannot write that. You have to write the exact definition. So what is the definition of electrolysis? It is the breakdown of ionic compounds. That's part 1. Okay, that's part 1. Breakdown of ionic compounds. Now, the ionic compound must be ionic in molten or aqueous, then only can conduct electricity. Because again, back to your old chapter, ionic compound, in order to conduct electricity, must be molten or aqueous. Why a solid cannot conduct electricity? Because no ions. Electrons is metal, so it's an ionic compound. So the ions must be freely moving. So breakdown of an ionic compound in molten or aqueous using electricity. So this is already a 3-mark question. Okay, this is a 3-mark question that they ask you if your teacher is doing electrolysis. Now, this is a common question that they ask in exam. So breakdown of ionic compound, molten or aqueous, 2nd mark, using electricity, 3rd mark. So it's a 3-mark question, a definition. Okay, can? Alright, so the parts of electrolysis. So it has to have a power source, battery. It has to have something that brings the electricity in. What brings the electricity in? Electrons. Okay, now, because we are doing molten, molten has very high temperature because you want to melt something. So the temperature has to be really, really high. So because of that, it is in the form of graphite. Do you remember what is graphite? Graphite is a macromolecule. It has a very, very high melting point. Okay, it can conduct electricity because only 4 of its electrons are used for bonding. Only 3 is used for bonding. The 4th one can conduct electricity. Okay, now when we are using molten, usually we don't use a beaker. Hi. Eugene? What time does class start, Eugene? What time is it now? Oh my goodness, you are late. No, this one. Never mind, never mind. Where are you sitting, Eugene? Okay, later when someone comes, someone open the door. Okay. All right. Okay. So graphite in molten or aqueous. So we need to use. So let's say we're using molten, we use a crucible. Eugene, did you watch the video? Yeah, sure. Okay. So molten, let's say molten sodium chloride, let's say. Okay, so we did this last week, right? Okay, now you must heat it up. You don't heat it up, how can it be molten? And then you need to use crucible. Okay, so when you're doing electrolysis, nobody's going to sit down there and tell you what's the formula. Immediately, you have to know sodium chloride is NaCl. Immediately, you have to know if it's molten, it breaks apart to sodium ion and chloride ion. Okay, now negative ion is called anion. Positive ion is called a cation. This thing, battery source. Sometimes they will draw this for you. Now, sometimes they draw a box for you and they will write here positive, negative. Teacher, I don't know how to draw this. Draw this now. So simple. So here is positive, here is negative. The positive will attract negative or positive? Negative. So because an ion will be attracted to the anode. Cation will be attracted to the cathode. Okay, the purpose of electrolysis is turning the ion back to original. Okay, so when this guy, sodium, wanted to become an ion, it threw away the electron, right? So now the ion want to change back. What does it do? Gain one more electron back lah. Okay, so at the cathode, the sodium ion will say, I'm not happy being an ion. I want to change back to original. So take back the electron and change back to original. Get it? Then the chloride ion will say, I'm not happy with my life. I want to change back to original. So the chloride ion will say, okay, I'm going to give back the electron. I don't want already. Okay, now, what is the thing about chlorine that we have learned previously before? Chlorine must exist as a diatomic. Who else? Fluorine, chlorine, bromine, iodine, oxygen, nitrogen, hydrogen. Have I written this millions of times? Yes. So, therefore, you have to put 2, 2, 2. Get it? So, overall, what happens here is you start out with ionic compound sodium chloride. Sodium chloride changes back to become elements sodium and chlorine. Have I completed the definition of electrolysis? Yes. Electrolysis is the breakdown of an ionic compound in molten or aqueous using electricity. Okay? Can I understand the concept? Alright. Okay, so this is what we did last week. Okay, last week we did all the molten, but we're going to do a quick recap. Okay? So, can you all please draw this and do this now? Okay, so it's using same concept, using graphite. Both of these are molten, huh? Everybody is using graphite. Okay? Can? Now, Both of it, I want you to write down the formula of lead 2 bromide lithium iodide. Teacher, I cannot remember the formula. Go to the list. Go to the list. Go to the yeah, I give you all a hint. Guys, list also must memorize. I know some of you cannot start because don't know how to write the formula, right? Lead 2 bromide, so it's PbBr2. Lithium iodide, so it's Lii. Okay? Lithium is +1. You know what you're supposed to do now? You're supposed to write the half equation in NO I cathode. Okay? Done? Done. Jackie done? No. Okay? Write the half equation. What is half equation? This is half equation. This one. Cathode anode. This is the half equation. Okay, for those of you who didn't realize, we did like 6,000 of them last week, this one. Okay? Ejin, you came late last week. I gave you the notes, right? Uh, we're going to be using it today. And also your exercise books. Okay. You came very late. You came towards the end and I passed you the notes. You said you had some recording and it ended very late. At all? Sure. That was last week. I gave you, right? You were here, right? You were not here. Huh? This one, wait, there's only this one. Oh, that's it. There's nothing else. Notes is you right now. You have this already.
Yeah, but I don't think this is included.
So you don't have this one. Then you take those. Done. You're done. Not done then? Okay, ready? Okay. Now, so cathode, the lead ion, 2 plus means receive 2 electron. Eh, sorry. 2 plus means add 2 electron become Pb. Okay, so for this one, lithium ion, give 1 electron become lithium. Okay, anode, bromide become bromine. Remember, bromine is Br2, 2, 2. This one is iodide, become iodine. Again, 2, 2, 2. Do you get it correct? Yes, okay, good. Okay, overall. Overall means I start with lead bromide, I become lead and bromine. This one, I start with lithium iodide, I become lithium and iodine. Get it? Okay. So if they ask you, what will you see? Okay, what will you see? They will ask you observation. So bromine at the anode, bromine you will see brown gas. Why will you see brown gas? Teacher, I thought bromine is a liquid at room temperature. Yeah, but it's molten. It's really, really, really hot. So because it's really, really hot, the bromine will become gas. Because it's really, really, really hot, the iodine will become gas. So it is a purple gas. Okay? And these two are what? These two are metals. So you will get a shiny metallic block inside your crucible. Okay, I showed you the video last week, right? Did I show you the video last week? Yeah. Okay, the lead to bromide electrolysis. Can remember? Can remember? Okay, so this is how you do electrolysis of molten. Molten is easy because there's only one cation, one anion. Okay? All right. Today we're going to level up. Okay. We're going to do the next part, which is called aqueous. Can or not? Need to do one more for, need to do one more for molten or not? Are you okay with this? Do I need to do one more for molten? Hello, yes or no? Okay, I do one last one. One last one for molten, then we will do something else. Then we do aqueous already. Okay. So electrolysis of molten. Oh, sorry, don't use zinc chloride. Use magnesium chloride. MgCl2. Okay. So write down all the ions present. Write down the half equation at the cathode and at the anode. Okay. Okay. Ready? Okay. What are the ions? Mg2 plus and Cl negative. Right. Did you get that? So cathode Mg2 plus receive 2 electron become Mg. Anode chloride becomes chlorine. Okay. Do you need to put 2? Yes. Can? Overall, MgCl2 becomes Mg and Cl2. Okay, so all of this is molten. All right, what is the problem with molten? It is very, very, very hot. Very, very, very high temperature. So in school lab, we usually don't use molten. In school lab, usually we use aqueous. So that's the part that we're going to do now. Okay, what does aqueous mean? Aqueous means dissolved in water. All right, can? Okay, so this thing you need to write down. So please write down. So electrolysis of diluted aqueous solution of sodium chloride. Okay, we are still using graphite, okay? Okay, done? You drop first, drop first. Drop first and explain. Now, ready? So, first of all, sodium chloride. Until today, you still don't know sodium chloride is Na plus Cl negative. I'm going to sit there and cry. Okay? Now, other than sodium chloride, what else do we have? I said it 3 times already. What else do we have other than sodium chloride? It's an aqueous solution, so it's dissolved in water. Okay. Okay, water ionizes to form hydrogen and hydroxide ion. H plus and OH negative. Hydrogen and hydroxide ion. Okay, so now we have a problem. How many cations do we have? Two. How many anions do we have? Two. Okay, so you have two cations and two anions. Okay, now during electrolysis, this one is positive, this one is negative. Positive is called the anode. Which anion will be attracted to the anode? Which anion will go there? One or both? Both. Both also will go there and say, pick me, pick me, pick me. And then the hydrogen and sodium both also will go to the cathode and say, pick me, pick me, pick me. Okay. Can you choose both or you have to choose one? One. Okay. You have to choose one only. All right. Okay. I'm going to write down the laws of how to choose. You might want to use another page. I write it big so that you will not forget it ever. Okay. Until your IGs are over. Can? Right. So, okay, let's now write down the laws. So when it's an aqueous, okay, so when it's an aqueous, means it has water. And water ionizes to form hydrogen and hydroxide. Okay, so how to choose? So the rule to choose for cation and the rule to choose for anion is different. Okay, can? Okay, cation easier. Now, one of the ion has to be hydrogen, right? The other one could be sodium, could be magnesium, could be aluminium. What is G mean? Group. So it could be a group 1, group 2, group 3 ion, sodium, potassium, lithium, magnesium, calcium, or hydrogen ion. Okay? Which one do you choose? If it's group 1, group 2, group 3 versus hydrogen, you choose hydrogen ion. Hi, Ariel. Were you here last week? No. Okay, good. Now we're doing aqueous. Guys, today in history, we almost have a full class. Actually, this Xuanyi, is he in class or not? He's actually attending my class. I haven't seen him in 3 weeks. I saw him once. I met him once. Is he coming or not? Like robotics competition for 3 weeks.
It's in China.
He's in China
Yeah.
for the competition.
Yeah.
Yeah.
China.
No, how come? Um, okay. Do you understand? So if it's okay. So if it's magnesium ion and hydrogen ion, which one do I choose? Hydrogen, because magnesium is group 2. If it's aluminium ion and hydrogen ion, who do I choose? Hydrogen, because aluminium is in group 3. Okay. If it's calcium and hydrogen, who do I choose? Hydrogen, because calcium is in group 2. Okay, can? So if it's group 1, group 2, group 3, you choose hydrogen. How do you know if it's group 1, group 2, group 3? You look at the periodic table. Do you have the periodic table? Yes, you don't need to memorize the periodic table like my little genius memorized. I have a little genius that I teach. He memorized the periodic table when he was 2 years old. He sat for his IG's chemistry last year. He got an A. He sat for his math. He got A star. He sat for his bio last round. His results are coming out in 2 weeks. Okay? So whatever you get for chemistry, you have to get higher than an A because if not, you will lose to that time he was 7 years old. Okay? Okay? Minimal. All right. If it is transition metal ion versus hydrogen, then you choose the transition metal ion. Get it? So it's so easy. It's basically whether it's hydrogen, whether it's group 1, group 2, group 3, or transition metal. Who is in transition metal? Silver ion, copper ion, nickel ion. Okay? So you only choose hydrogen when it's group 1, group 2, group 3. If it's not group 1, group 2, group 3, you choose transition metal instead of hydrogen. Okay, Ken, do you understand? Guys, get it? Now, anion, if it's nitrate or sulfate, okay, never, ever, 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 ever choose nitrate or sulfate. I say this right. Some magic can still happen in the exam where you choose nitrate or sulfate. Okay, so if it's nitrate or sulfate, choose hydroxide. Okay, if the anion is nitrate or sulfate, choose hydroxide. Okay, which comes to the last part. Chloride, bromide, iodide versus hydroxide. Okay, last part. If it is concentrated, choose chloride, bromide, iodide if it's concentrated. If it's diluted, then choose hydroxide. If it's diluted. That's it. So basically, it's whether it's diluted or concentrated. If it's diluted, you choose hydroxide. If it's concentrated, you choose. Can? Is it clear? Easy? Okay. Okay, I take a screenshot also for you. And then you can go home and tattoo this in your brain or your wall, whichever you can. Okay? Who is Hayden?
Yeah.
Hayden Chin. Is someone's parents?
Oh yeah.
Or that your dad joined already? Okay, so all okay. Can do you all understand? Okay, so look at this. With your newfound knowledge, who should I choose in the cation? Hydrogen, because sodium is in group 1. Okay, so I don't choose sodium. Chloride and hydroxide, who do I choose? Hydroxide, because it's diluted. So you know it's diluted, teacher, because I wrote it down. Okay, so you don't choose because it's diluted. Get it? So in the cation, at the cathode, hydrogen receives electron to form hydrogen gas. H2SO22. What will you see? What will you see? Hydrogen gas is a gas. What can you see?
Clouds.
Bubbles. So you see bubbling or you see effervescence. What is effervescence? Bubbling. Is it the same thing? Yes. Can I write either one? You write whichever you can spell. Okay? So you see bubbling. I can only spell bubbling. I don't know how to spell effervescence. Okay. Chloride won't be chosen because it's diluted. I choose hydroxide. So at the anode, hydroxide, the equation is a bit more complicated. Write this down. Hydroxide becomes water, oxygen, and releases 4 electrons. This one you have to memorize. I cannot do anything. Okay. So this is the half equation at the cathode. This is the half equation at the anode. So will you also get bubbling? Because here also got oxygen. So you will also get bubbling. It's just that one side is oxygen, one side is hydrogen, but you can't tell the difference. You can't see. Okay, do you understand? You understand? Okay, one last part. So I started with sodium, hydrogen, hydroxide, and chloride. Okay, this one was chosen. This one was chosen. Are they both from the same compound? Yes, no? H and OH, are they both from water?
Yeah.
Yeah, so basically, this is the electrolysis of water. So the overall equation would be, you started out with water, water breaks down to hydrogen and oxygen. This is called electrolysis of water. This is how we get hydrogen and oxygen in the industry. Okay, this is how they get pure water, pure hydrogen, pure oxygen. One of the ways, not the only way, but one of the ways. So this is the overall equation. Okay, can? Now, if I take away water, what's going to happen to the solution? It will become concentrated or diluted? Concentrated. Okay. Now, when you're done, please take out last week's notes. The last page. Everybody done?
Wait, that's done.
Done? Oh wait, yeah, you're not done.
This side.
Done. Okay. So look at the last page. Okay. Last week we did the molten. Today we're gonna do the aqueous. Okay, so basically this is what we just did lah. Okay, so do you understand this basically what we just did? Electrolysis of the molten one we did last week, right? Yeah, okay. So cation, so sodium chloride, right? Okay, so cation was sodium and hydrogen. Anion was chloride and hydroxide. And then the half equation. And this one half equation. Overall equation. Get it? Okay. So I want you to try this one, concentrated. It's still sodium chloride. It still has water. Why?
I need to last week. Well,
Maybe I put paper already. I don't know why. Somebody must have put extra. I don't know why I don't know already. Can you write this down first, Ariel? I asked Mr. Kong whether he can print out one more. Hey, do the second one. The ions are the same, it's just concentrated. Okay, okay. All right, so it's concentrated sodium chloride. It's the same ions. It's just concentrated. You know, it's like you go mama lah, you ask for Milo pekat, Milo cow. Okay, Milo cow still have water, right? You just more water or less water? Less water, more Milo lah, right or not? Then the Milo you make in the house, more water, less Milo lah. Same concept, diluted and concentrated. It has the same things. So hydrogen, who do we choose? Now that it's concentrated, we still choose hydrogen. Why? Because I give you the list. You always choose hydrogen if it's group 1. Get it? Okay. So you still choose hydrogen. So it's exactly the same. Now, when it's concentrated, chloride and hydroxide, who do you choose? Chloride. Okay, this overall will be a little bit tricky. I'm going to teach you on the other side. You all done with these two?
Yeah.
Hannah? Okay, so, Pia? Okay, so, this. Okay, just now we did this, right? It's concentrated, Now, here's where it's a little bit, not complicated, a little bit different. So sodium, chloride, hydrogen, hydroxide, right? Okay, who did we choose? Cathode, we choose hydrogen. Who do we choose? Anode, we choose chloride. So who is left in the solution? Sodium hydroxide. Sodium hydroxide is an acid or an alkali? Alkali. So what happens is, here it's not just water, it's two different compounds. So we have to write for the overall equation, we have to say sodium chloride. So for this overall, I'm writing it here, okay? We started out with sodium chloride and water, okay? In water, we chose hydrogen ion to become hydrogen gas. There, get it? In sodium chloride, we chose chloride to become chlorine. So who was left over? NaOH was left over. Can you see this? So this is the overall equation. You get bubbles, bubbles, and what's left over. So they will always like to ask you, what is left over in the beaker? Okay, and then balance this equation. Do you understand?
Yes.
Do the rest. Now, Ariel, I sent to you, okay? I see Mr. Kong haven't replied me yet. Okay, I guess done with this one? Yes, huh? Okay. Huh? Done with it, huh?
Yeah.
Okay. So do the rest. Do the rest now. Okay, so all of them got solution, whether it's concentrated, diluted, it all has solution. Okay? Okay. Potassium, sulfate, and water. Okay, if today, 1st August 2026, You still don't know who is what? We all sit down and cry together and sing Kumbaya, okay? You cannot say everything don't know, don't know, don't know, don't know, yes?
I think you're wrong. Sit around.
All right. So if you're not sure, please go and refer back to the old videos. Okay. So concentrated potassium sulfate is potassium. Okay. You cannot write formulas wrong, potassium and hydrogen. So you choose hydrogen. You need to improve your handwriting. If people cannot understand you, it doesn't matter how smart you are. They need to be able to read what you write. Okay? Sulfate or hydroxide? Hydroxide. So is this the same as electrolysis of water? Yes. So it is water becomes hydrogen and oxygen. Okay? Concentrated calcium and bromide. You still choose hydrogen because calcium is in group 2. This one concentrated, then you choose bromide. You get it correct? Yeah?
Yes.
Yeah? Correct? Okay. Overall, now this one's a little bit different. You start with calcium, bromide, and water. You end up with calcium hydroxide because that's what's left over. This one and this one and this one is chosen. So this and this is left over. Becomes this. Get it? Okay, and then who is left? Who else is made? Hydrogen and bromine. How to balance equation? Cool. That's it. Okay. Silver nitrate. Who do you choose? Silver or hydrogen? Silver. Because who said why? Because silver is a transition metal. Silver is a transition metal. Nitrate or hydroxide? Hydroxide. So this one you have written about 2,000 million times already. Okay. You start out with silver nitrate and water. Okay. Silver hydroxide is chosen. Who is left? HNO3. What is HNO3? For 1,000,000 points. What is HNO3? Nitric acid. Okay. Silver, oxygen. Okay, how to balance this equation? Write this down and balance it now. Quick, quick, quick. Balance ready? Now, I give you a trick on how to balance things. Okay? One silver, right? Nitrate, right? Here got how many hydrogen? Two. So you put two here. Okay. Wait, not yet. Who's the element here? Silver and oxygen. Oxygen, you always do it last. Okay, now oxygen here, how many? One. But here got two. So you put half. Okay, now half times two is how much?
Two, one.
Half times two is one. So now is everybody balanced?
And
Yes, but half is very ugly. So what you do is you take the whole equation times two. Take the whole equation times two. So 1 times 2 is 2. 1 times 2 is 2. 2 times 2 is 4. 1 times 2 is 2. And half times 2 is 1. So now it's a balanced equation. Get it?
wow.
So amazing, right? When you use your brain. Yeah.
Brings three out.
2, 2, 4, 2, 2, 1. Okay?
Actually, you.
Jasmine, copper socket.
Subfusions.
Choose copper ion. Choose hydroxide. Who is left? What is left? Hydrogen and sulfate makes what?
Sulfuric acid.
Sulfuric acid. H2SO4. Okay? How to balance? Do the same magic method. Okay? One copper, one sulfate, two hydrogen, two hydrogen. Half lor, same thing lor. So you just double everybody except for oxygen lah. Ta-da! Done already. Good. Now learn.